Hello, everybody. Welcome to my final project presentation. And thanks for everybody who opened this video to watch my presentation. So this project, we are going to analyze if the customer will cancel the loan and how different features will impact their decisions. So the whole project it will be individual into 5 parts. It will be data understanding, data processing, business intelligence, and model building. The last part will be implication. So the first part here, we just basically look at how data looks like. So we can see it comes with 48 columns. And then we can also tell some of the columns come with just none, none. So we're going to handle them later. So basically just look at the information. It also comes with a lot of different type of data here. And we can also tell from like a later charge and then some other information here, which is weird. Like they do not have the same count, and also something they're negative. They shouldn't be negative. Something. So we basically to see the customer who cancel the loan and who do not cancel the loan to see, we can tell like okay, some of the column like agent rejected this kind of column here. There are no much difference between the customer who cancel the loan and who do not cancel the loan. So this kind of column, we are going to drop them off. And now just look at the correlations, but we can see we have so much column, so it is hard to tell to get that much clear information from this kind of table. So we're going to processing the data here. So we just drop a lot of column we are not going to use here. And then we just check kind of information about the data. So we can tell here, we have some missing data, like exposure, it means like 7 data. Browser credit score means like 46,000 data here. So we're going to handle them. So we're going to first handle the browser credit score here. We found out like there are 7,689 rows, they are missing data. So we basically just drop them off. And then we just look at our new, how many data we are missing here. And then we're going to handle the exposure. We found out like most data here that belong to 0, which is cool. So we just replace the num with the zeros. And then we are going to handle the risk score and the bank red flag. So basically for the risk score, we're just going to drop them off because it is hard to get a conclusion without historical data. So we just drop them off. So this is how the data information looks like now. And we can tell from here the later charge and also the exposure, it comes with negative information. It shouldn't be negative number. So we are going to transfer the negative number into the 0. So now the data set looks way better. And the next part, we're just going to handle some of the columns here. I create a new column which called terms difference. Basically is the duration between column terms and the payment received. Because we're trying to find out like if some of the customer, they just do not pay the payment on time, if that will impact their decision or not. So we can look at our table here. We can look at like a default charge. They have like a much difference. So we can say like, yeah, default charge and then also NSF premium and then they probably impact the customer's decisions. So we also can tell like the data here, like we discover from the data that most borrowers are distributed in Texas and LA, and the customer who cancel the loans higher default charge, and it is almost 5 times as much as the customer who do not cancel the loan. They have a higher NSF charge. That means they cannot pay their payments on time, and low exposure terms different. They're huge. And we also can tell from the table the customers who make a loan, most of them belong to service industry, real estate, and general. So we'll just make a couple plots here to see if there any information we can get from the tables. And we can see customers who usually make their loans with 9 turns and 11 turns. That is huge information. So most people choose to make the long term from A to terms. So the bank can come out more financial plan to the customer in the periods from A to terms without wasting too much resource. So these are some of the information we got and some of the plot we created. So basically, the customer who cancel the loan usually because they have a longer loan terms, but they also cannot pay them on time. The total amount financed is increasing while the term is increasing. Most people who canceled the loans usually are in the range of 8 to 10 terms. So we look at the correlations. Now it's way more clear than before. And now we are going to building our model. So the first one will be classification. We basically just drop some of the column we are not going to use and transfer whole data into the same data type, because that will be helpful us to building the model. And here, just basically a plot we build, we can see most customer, they do not cancel their loan. So we're trying to classify like who will cancel the loan, who do not cancel the loan here. So this is the how I build the model, and we can see the accuracy for the model is like around 94%. And then we have 99,400 customers with who do not cancel the loan, and the 46 customers cancel the loan. And then basically this is how we got our classification here. I'm sorry the presentation cannot show the whole plot, but basically it show like how we make the classification for this model. So this is the conclusion we found out from this model. So we discovered that when terms difference less than 0.5, little charge less than 0.5, default charge less than 0.5. I'm sorry, I didn't type it out. So the customer will choose to cancel the loan. We can also say the model's accuracy is 94%. Most of the time, customers choose to maintain their loads, and the main classification factors we can find from the plots are the terms, these kind of features. And then the next one will be regression model, and then the dependent variable here we use is premium. So we just basically drop some of the column and check data's information if they are correct or not. Sorry about that. And then just like how we build the model, and then we find out like we try to make the models being a symbol, but at the end we just drop the payment received these columns. So we are trying to find out like the two of the most important factors impact our dependent variable. So we found out is the fourth and the fifth. So the way we find it, like this one is 0, 1, 2, 3, 4, 5. So the models we discovered now and the FIN CHG columns are the two most important predicts for our regression model here. So we just build our model and then we get a coefficient and the y-intercept. So this is basically how our regression model looks like. And then we do the same thing while we're trying to find out the best 3 predictors. And this is our new model. And then we're trying to find out the best 4 here. And this is our conclusion while we have the 4 predictors. But we find out like R-square is increasing, but it doesn't changing a lot while we increasing the predictor from 3 to 4. However, each x variable we added will increase R-square, but it does not mean the added predicts can predict the model better. So here we're just trying to look at the summarize. And here we can get information from the previous slide I showed you guys. So we basically look at the R-square and ADJ R-square here. We found out like the second model and the third model's R-square are the same. So we would like to maintain the regression models as simple as possible. So we choose the second model as a regression model here. And then the third one, it will be clustering. So we just basically, we are trying to handle some of the data here, like I did before. So we are trying to look at the variance about the data. And here, we are trying to normalize the data. It will be helpful for us to building the model. So this is a data set we make after we normalize the data. And then we can use this coding to find out like how many clusterings we made that will be better for our model. And then we find out here the 3 will be the best. So basically this coding to show you guys how I build the model, and then this kind of data information here. So we found out how each row belong to which clusters. So we're going to merge 2 tables together, but we can see we found some problem here. Some of the clusters, they belong to none. We're going to handle that. It's just because the table does not join in a proper way. So we just reset the index here and then join again. And then the whole data set looks way better. Excuse me. And then we just make out some of the plots here. We basically want to see like what kind of cluster belong with what kind of factors. And we can see here the customer with down payments like over 200,000 that belong to one, with over 100,000 belong to one, with majorly belong with 50,000 belong to one. And then we also can tell like the customer with a huge durations in terms that belong to one, and then the ones building in here in the 2.5 to terms belong to one, and the ones from 0 to terms belong to one. And we can tell here the terms difference. So the customers who have the terms difference from 0 to 4, they belong to one clusters. The customer belong to 3 to terms belong to one. So we can get a lot of the conclusions for our clustering models. So we can really cluster different set of the group based on terms, down, and the premium. The bank can really choose to service the customer in different clusters to provide a better and special service plans for the customer. And we can see the term difference around 3 to 10 is set at the second cluster. And we can tell from the API upload then the cluster is divided into 3 when the cluster having different APR. So we have the sum of the conclusion here. So the bank can use the clustering model to separate the customer into different sections. That will be helpful in setting out special loan plans for the customer in the specific cluster. In this way, the bank can deduct the resource waste and focus more on the satisfying customer specific demand. The regression model can help bank to predict if the customer will be a loyal member for the bank based on their downs exposure and FINCH. So basically, this is how I analyze my final project, and then the conclusion I got from the whole building models. And I'm saying for everyone who watched this video and saying for the listening. Thank you so much.